All right, ladies and gentlemen, today we are going to be talking about converting mixed to improper. And that really means converting mixed numbers to improper fractions. And on the last few pages, you've seen what that means. It means we're taking a number that has a whole number and a fraction and turning it into a fraction where the numerator is larger than the denominator. So I'm going to start with a pretty simple fraction, or a pretty simple mixed number, I should say. It's 2 and 1/4. Now today we're going to talk about how to make these conversions using pictures. So I'm going to draw a picture of what 2 and 1/4 looks like. I know I have two wholes, and then this fraction tells me I have part of another whole. So what that means is I'm going to start by drawing 3 wholes. 1, 2, 3 wholes. And again, that's because I know I have 2 wholes, and I know this fraction tells me I have part of another whole. Now the denominator tells me how many parts each of these wholes is broken up into. 4 parts. So I'm going to neatly divide each of my wholes into 4 parts. Okay, so I'm going to start with my whole number, and this whole number tells me that all of this one whole and all of this one whole are going to be completely shaded in. So I'm going to shade them in with a pencil. Every single part in each of these holes is shaded in, and that represents 2 wholes. Now in this last hole here, I only have 1/4 of it shaded in. So out of these 4 parts, I only have one of them shaded in. So that's a visual of what 2 and 1/4 looks like. Now what I need to do is make this an improper fraction. And no matter what, my denominator is going to remain 4. So I'll write my 4 over there. Now, how many fourths do I have colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9/4 colored in. Okay? So let's try another problem. Let's try 1 3/5. So I'm going to neatly write 1 3/5. And what this fraction tells me is I have one hole colored in and then part of another hole colored in. So I'm going to draw one hole and then another hole. And I know each of those holes is divided into 5 parts. So I'm going to do my best to neatly divide each of these holes into 5 parts. All right, because of that whole number, I know one hole is colored in completely, and I know 3/5 of the next hole is colored in completely. So again, I'm going to color in all of the fifths in this first hole because I know I have the whole thing. And then I'm going to color in 3 on this second one. Okay. Now, in order to take this mixed number and make it improper, again, I know I'm going to keep my denominator, which is what? Right, my denominator is 5. That's not going to change. And now I need to count up the amount of parts I colored in. 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 parts colored in, which means I have 8/5. Okay, so that's another example. Let's do another one that's kind of basic. Let's do 2 2/3. 2 2/3. All right, so I want you to think about this. If I have 2 2/3 as my fraction, how many holes am I going to need to draw? Think about that for a second. All right, if you said 3, you're right. because 2 of the holes represent that whole number. And then I need one more hole that's going to be partially colored in. So 1, 2, and 3. And each of those holes is going to be divided into how many equal parts? If you said 3, you're right, because we need to look at the denominator to figure that out. So each of these is divided into 3 equal parts. Okay, now I have 2 holes that are completely filled. 1, 2. And then my last hole is partially filled. So I can color this in like this because I know this one is fully used. I know this one is full because it's 1 hole. And I know in this, oops, I forgot to draw my line there. And I know this last one, I have 2 out of 3 parts. Okay. Now, in the previous examples, I've numbered them, but another thing you can do if you're really good at skip counting is look at your denominator. For each hole, you skip count by that number. So I know this hole represents 3 parts, and if I skip count, this hole will give me 6 parts. And then for my last one, I'll count 7, 8. So I know 8 is my numerator and 3 is my denominator. If you're not comfortable with skip counting, that's okay. You can always just write down the numbers inside the parts of the hole that you have colored in. And that will also equal 8/3. I'm going to do one last one that's a little bit more challenging. I'm going to slide my paper up a little bit here because you will see some problems like this. This next one is going to be 8 and 5/6. So this one's going to require a little bit more drawing, which means there's a little bit more room for mistakes. 8 and 5/6. How many holes do I need to draw to make a picture of 8 and 5/6? If you said 9, you're right, because I have 8 holes and part of 1 more hole. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so 9 holes because I have 8 holes here and part of another one. How many parts are each of these holes going to be divided into? The denominator is the number that tells us that, so yes, 6. So when I divide into 6, I like to do 3s going down and then 1 line across, which gives me 6. That's how I divide them the most equally. So each of these will be into 6 parts. Now, as you can tell, this takes a little bit longer when you have to draw more holes and divide them into parts, but it's important that you do it neatly and carefully so that you get the correct answer. Okay, so we have 9 holes there, and each of those is divided into 6 parts. Now I know that 8 of these are fully colored in. So I'm going to fully color in 1, 2, 3, 4, 5, 6, 7, and 8. I know each of those is completely colored in. And then in my last hole, only 5 are colored in. 1, 2, 3, 4, 5. So I can see that that last one is left open. Okay, so now I need to count up each of these parts in here. Now this is where skip counting comes in really handy, because if I can skip count by 6s, I know that each of these boxes or each of these holes is going to be worth 6 parts. So 6, 12, 18, 24, 30, 36, 42, 48, 48, but now I can't count this as a whole. 49, 50, 51, 52, 53. So 53 will be my numerator. And what is my denominator going to be? The same as it was, because each of these are broken up into 6 parts, 53 sixths. If you're not good at skip counting, you could write in each of your numbers, but you can see it just takes quite a bit longer. And when you have small drawings, you have to write pretty small. We've talked this year a lot about how important it is to be able to skip count and know your basic facts. So this is a testament to why we say that. It makes your life a lot easier than writing out all these things. So you can see I came up to the same number, 53, as I got here, but it was a lot easier for me to say 6, 12, 18, 24, 30, 36, 42, 48, 49, 50, 51, 52, 53. So it went a lot quicker that way. So ladies and gentlemen, this is a quick example of how to convert mixed numbers to improper fractions by using drawings. Okay? If you have any questions, reach out and please complete the activity on the next page in your slideshow.